In this video, we'll be reviewing section 3.3 on dividing polynomials. We'll be looking at long and synthetic division and also the remainder theorem. Let's look at dividing polynomials using long division. So in our example, we have a trinomial x squared plus 10x plus 21 divided by the expression x plus 3. To set up our long division, we're going to put x squared plus 10x plus 21 underneath the division sign, and then we're going to put x plus 3 as the divider. Next, we're going to look at x plus 3 and x squared plus 10x, so the very first two terms in each of the expressions, and we're looking for a common factor, and we see that x is the common factor between both of these expressions, so we're going to put an x here, and then we're going to go ahead and multiply. We're going to say x times 3 is 3x, and x times x is x squared. And then we're going to subtract, just as we would do with a regular long division. So x squared minus x squared gives us 0, plus 10 subtract plus 3 gives us 7x, and then we bring down the 21. Next up, we're looking at x plus 3 and then the 7x plus 2, 1, and the common factor with these are going to be 7. 7 times 3 gives us 21, and 7 times x gives us 7x, and we have 0. So when we divide x squared plus 10x plus 21 divided by x plus 3, our answer is going to be x plus 7. Let's look at another example. We have x squared plus 45 plus 14x divided by x plus 9. So x squared plus 14x plus 45 is the first thing you want to do. Is you want to arrange the polynomial in descending order for the variable. So I just switched these two numbers around. So we'd have x squared plus 14x plus 45, and then we're dividing that by 9. Looking at the first two numbers in this expression, x seems to be the common factor, so x times 9 is 9x, and x times x is x squared. We're going to subtract everything. We'll get 45 here. 14 minus 9 gives us 5x, and x squared minus x squared is equal to 0. And then x plus 9 goes into 5x plus 45. 5 seems to be the number here because 5 times 9 does give us 45, and 5 times x gives us 5x, remainder of 0. So the answer in this case is going to be x plus 5. Let's look at a more complicated example. So in this one we have 4 terms that are being divided by a binomial. First of all, when we arrange our polynomial, we want to have it arranged in descending degrees. So 6x to the cube minus x squared minus 5x plus 4 divided by 3x minus 2. So I'm going to look at taking 6x to the power of 3 minus x squared and dividing by 3x minus 2. In other words, I'm looking at what do I multiply 3x by 2 to get me the closest to here. Well, I'm looking at 3x, and I know it can go into 6x cubed 2 times, and 2x squared, so that when I go 6x to the power of 2 times 3x, I'll get 6x cubed, and 2x squared times negative 2 will give me negative 4x squared. So then when I go ahead and subtract, I'll bring my rest of the expression down, and negative x squared minus negative 4x squared, well, that's the same as adding a positive 4x, like so. So negative x squared plus positive 4x squared is going to give me 3x squared. And then I need to make sure that I remember that this is actually subtracting. 6x cubed minus 6x cubed is 0. Then I'm going to go ahead and go 3x goes into 3x squared plus x one time, because x times 3x will give me 3x squared. So x times 3x is 3x squared. X times negative 2 is negative 2x. Subtract. We're always subtracting in long division. 4 minus 0 is 4. Negative 5x minus negative 2x, that's the same as adding. So negative 5x plus 2x will give us negative 3x. And then just remember that this was negative, and 3x squared minus 3x squared is 0. And then lastly, 3x minus 2 goes into minus 3x plus 1, negative 1 times, because negative 1 times 3x gives us negative 3x, and negative 1 times negative 2 gives us positive 2, with the remainder of 2. Now this remainder is something new. What do we do when we have the remainder of 2? Well, first of all, we're going to write our answer here. Our answer in this case is going to be 2x squared plus x minus 1 plus the remainder of 2, but remember it's actually 2 over 3x minus 2. We always want to take the remainder and put it over what we were dividing by. Put it over the divisor, and then that becomes our answer. So our answer to dividing 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2 is 2x squared plus x minus 1 plus 2 over 3x minus 2. Let's look at one more example using long division. Okay, here's another example. First of all, we're going to set up our long division. We want to make sure that our variables are in descending order, but also in this one, we have to make sure that all of our variable degrees are given. And you can see that there wasn't an x squared in the variables for this polynomial, but we need it for a placeholder in long division. So I'm going to include 0x squared plus 3x minus 5. If I don't include that 0x squared, I might have difficulty when I divide in terms of my place values for my answer. So when you're rewriting your number in descending order, make sure that if there are any degrees missing, that you make sure you include that. So I'm looking at 3x squared goes into 6x to the power of 4. I'm thinking 2x squared, and then 2x squared times 3x squared is 6x to the 4, and 2x squared times negative 2x is going to give me negative 4x cubed. Then I'm going to subtract these, and I get 6x to the power of 4 minus 6x to the power of 4 is 0. Positive 5x cubed, subtract negative 4x cubed, that's the same as adding. So I'll get 9x cubed, and then I'm just going to bring down the rest. And next I'm going to say, okay, 3x squared goes into 9x cubed. That's going to be 3x times, and 3x times 3x squared is 9x cubed, and 3x times negative 2x will be negative 6x squared. Subtract these. 9x cubed minus 9x cubed is 0. 0x squared minus negative 6x is the same as adding 6x squared, so it will just be 6x squared, and then 3x minus 5. And then 3x squared goes into 6x squared positive 2 times. 2 times 3x squared is 6x squared. 2 times negative 2x is negative 4x. And we'll subtract, and I need a little bit more room. And 6x squared minus 6x squared is 0. Plus 3x, subtract negative 4x, that's the same as adding positives. So I'll get 7x there, minus 5. And that's going to be my remainder because 3x squared minus 2x does not go into 7x minus 5. So when I write my answer, when I have a remainder, first of all, I'm going to take what I got for my solution at the top, and then I'm going to add my remainder divided by what my divisor was. So don't forget, when you do have a remainder, you need to include that in your answer by putting it over whatever your divisor was in the first place. So in the previous slides, I was showing you the long division strategy for dividing polynomials. The next strategy I'm going to show you is synthetic division. Now in synthetic division, we're going to use the same principles of long division, but we're going to simplify it a little bit. First of all, let's look at where the numbers come from. The 3 in the synthetic division comes from the 3 in the divisor. The numbers on this first row of the synthetic division are the coefficients of the numbers that are under the divisor sign. So x to the power of 3 has a coefficient of 1, and there's the 1. X squared has the coefficient of 4, and there's the 4. X has a coefficient of negative 5, and there's the negative 5. And then our constant is 5. The next row in synthetic division comes from these numbers here. And then lastly, the final row of numbers, right here, that is going to be what turns out to be our answer. So x squared plus 7x plus 16 are the 1, the 7, and the 16, and this last number here becomes our remainder. So let's look at an example of how to solve a division problem using polynomials using the synthetic division strategy. First of all, what we're dividing by needs to be in the form of x minus c, which it already is, so we're good on that. And then we're going to use whatever we're subtracting as the first number in our synthetic division. And we write it like this. Next, we want to write down the coefficients for the polynomial that we are dividing. So x to the power of 3, its coefficient is 1. 4x to the square, its coefficient is 4. And remember, if we are missing any of the degrees, we want to make sure we put them in. But none of our x's are missing any degrees. So this becomes our very first row. Now our next step is to draw a line and drop the very first number from that top row. Now we're going to get our second row. We're going to multiply the 3 times the 1, and that's going to give us a 3. Next, we're going to add 4 plus 3, and that gives us 7. Then we're going to multiply 3 times 7, which gives us 21. And then we're going to add down negative 5 plus 21 gives us 16. 3 times 16 gives us 48. And 5 plus 48 gives us 53. Now we can use this final row to solve for our quotient. The first number is always going to be 1 degree less than the largest degree in our dividend. So if our largest degree is x to the power of 3, then this one is going to be 1x to the power of 2. And then plus 7x plus 16, which means that we have a remainder of 53. So the key here is that whatever our first number is, that is going to be the coefficient of our variable that is 1 less degree than our highest variable. Now our answer, when we write it out, will be x squared plus 7x plus 16 plus 53 over x minus 3. And that would be our answer. Okay, let's look at a couple more examples just to get the hang of this strategy. So first of all, when we are doing synthetic division, our divisor has to be in the form of x minus c. And when it's not in that form, then we need to change it to be in that form. So x plus 2 becomes x subtract negative 2, and negative 2 is what is going to become our c in this part of our synthetic division. So if it's x minus a number, we can use that as the positive form. If it's x plus the number, then we're going to change that to its negative form. So that's what we're starting off here. And then looking at our dividend, we're just going to take our coefficients for each. So the coefficient for in front of x to the power of 3 is 5. You'll notice we don't have an x to the second degree, but we still have to make sure that we include that number. So that's going to be 0. And then x to the power of 1, that coefficient is 6. And then we have 8. We're going to draw a line, and we're going to drop the 5 down. So we've dropped that down. And then we go negative 2 times 5 equals negative 10. And 0 plus negative 10 is negative 10. Negative 2 times negative 10 is positive 20. 6 plus 20 is 26. And negative 2 times 26 is negative 52. And 8 subtract 52 is negative 44. Then we write out what our answer is, our quotient. 5 is going to be the first one, and it's always going to be 1 degree less than our highest degree. So that's going to be 5x squared minus 10x plus 26 with a remainder of negative 44. And then to write that, to include that remainder in our answer, our final answer is going to be 5x squared minus 10x plus 26 minus 44 over the divisor of x plus 2. And now for our last example, again, we want to have our divisor in the form of x minus c. So we'll get x subtract negative 2, and negative 2 will be the value that we put over here. Then we want to write down the coefficients for our dividend. So it's going to be 1 for x to the power of 3, 0 because we don't have any x to the power of 2, negative 7 for x, and then negative 6 is our constant. We draw our line, drop the 1, and then we multiply. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 gives us positive 4, and negative 7 plus 4 gives us negative 3. And negative 2 times negative 3 gives us positive 6, and negative 6 plus 6 gives us 0. The 1 becomes our quotient for our variable that's 1 degree less than our highest one, so we'll have 1x squared minus 2x minus 3, And you can see that we don't have any remainder. So so my final answer, I can just take out the 1, and my quotient is going to be x squared minus 2x minus 3. Out of synthetic division, we find an interesting trick called the remainder theorem that can help solve an equation given an x value. So traditionally, if you are given a function where something is equal to x to the power of 3 minus 4x squared plus 5x plus 3, and you're given that the function x value is equal to 2, normally what we would do is to solve this, we would put 2 in for all of the x values, and then solve for the equation. So 2 to the power of 3 is 8, minus 4 times 2 squared, so 2 squared is 4, and minus 4 times 4 would be minus 16, and 5 times 2 is 10, and then plus 3, and we get an answer of 5. You can do a trick using synthetic division to solve the equation when you know that x is equal to 2. What you do in this case is you take what x is equal to and you put that in as the divisor. Then you write down the coefficients of your expression. So for x to the power of 3, my coefficient is 1. Minus 4 is my coefficient for x squared. Plus 5 is my coefficient for x. And then plus 3 is my coefficient is my constant. Then I drop the 1, and then 2 times 1 gives me 2, and then add negative 4 plus 2 gives me negative 2. 2 times negative 2 is negative 4, plus 5, add negative 4 is plus 1, and 2 times 1 gives me 2, and 3 plus 2 gives me 5. Whatever I get as my remainder in my synthetic division, when I divide by what x is supposed to be equal to, that will actually give me the answer to solve the equation. So it's just a fun little check that you can use the remainder theorem to see if you are correct when you're solving equations, knowing what the x value is. Here's one last example to show the remainder theorem. Let's do the remainder theorem first. Let's take the equation of 3x cubed plus 4x squared minus 5x plus 3 and solve it when x is equal to negative 4. But we'll use the synthetic theory first. Negative 4 is what x is going to be equal to, and then using synthetic division, I get 3 is my coefficient for x3, 4 coefficient for x squared, minus 5 for x, and then 3. And if I was missing any of those variable degrees, I would have put a 0 in. I'm going to drop the 3 here. So negative 4 times 3 is 12, negative 12, sorry. And 4 plus negative 12 is going to give me negative 8. Negative 4 times negative 8 is positive 32. And positive 32 plus negative 5 is 27. And negative 4 times 27 is negative 108. And 3 plus negative 108 is negative 105. Now, according to the remainder theorem, the remainder should be what f of negative 4 is equal to, which should be negative 105. Let's check to see if that is true. So f, when x is equal to negative 4, we should get 3 negative 4 cubed. I'm going to need a little bit more room, so I'm just going to do that for a moment. Plus 4 times negative 4 squared minus 5 times negative 4 plus 3. I'm going to go ahead and simplify. Negative 4 cubed times 3 is negative 192. Negative 4 squared times 4 is positive 64. Negative 5 times negative 4 is positive 20 and plus 3. And then when I add all of those together, I get negative 105. And yes, the remainder theorem works. So just a cool trick to do a check when you know what the x value is for a function. You can always use the strategy of synthetic division to do a check to see if your solution is correct. Well, that's it for section 3.3. Thanks for watching.